Alright, cool, we're live. I'm going to look at the Ethereum APIs and protocols a bit more today. So, I have previously been looking at the Ethereum node, which gets started, and as part of the node, it offers services. And a service is literally just something that can be started and stopped. This APIs array here is what the service offers to someone trying to call these remote procedure calls on them. So when you run the service, the point of running Geth is you have these ability to call remote procedure calls on the structures that are internal here. So you're running the node, and then on another program or script or something, most likely the Web3 JavaScript library you're running, you can call functions internally and it will give you the state and stuff. So that's what this API is exposing, all that stuff to the remote procedure interface that you can call from whatever, the Web3 being the most common. So the first and foremost service that is being offered by the node is this Ethereum service, I guess. So it implements the start and stop, which we had a bit of a look at the other day. And now I'm looking at this API's function, which is returning a list of remote procedure calls. First of all, it digs up some other APIs that are offered by what is this backend and the blockchain engine. But we'll just look at this because it's calling this new public Ethereum API function, which is over here. And that returns this structure which just has the Ethereum node in it. And then it exposes a heap of function calls. So you can call Etherbase, you can call Coinbase, you can call hash rate, chain ID, public miner, and all they are doing is they are wrapping the internals of the Ethereum structure. So the Ethereum structure is where pretty much everything to do with Ethereum is being saved. It's got the database that they're writing to. It's got the blockchain and the states. Everything is saved in this Ethereum structure. So the API engine is mining call, returns a boolean if it is mining. If it's not, public miner API. That's a miner API, which is here. You can also call chain ID, and all that does is it goes through and digs up the chain ID, which is 1 if it's a mainnet, 2 if it's 2 doesn't exist, I think 3 and 4 are test nets off the top of my head. But they're really just a bunch of functions that if you were calling the package internally, you would have no problem calling this hash rate function, this chain ID function. Because they're not being called internally, there is a server set up to listen for remote procedure calls, it receives requests and translates them into this this function here. And the requests come as JSON, I believe. So there's a JSON request being posted to it. And then it will call these functions depending on what gets posted to the RPC server. So we can kind of see here that it's going through, adding all these and it's pretty much whatever you set your configuration as. Geth API config. Geth startup configuration file. No. So you can set what is being added as a API here. So if you're enabling the RPC server, the web server, yeah. So there actually isn't too much. The whole purpose is just what is being offered by this RPC server is determined by these lists. So the other side of it I wanted to look at is that the service offers protocols. Which I believe at this point is the custom protocols that are being made by the dev P2P. And I guess somewhere in here there'll be a call for protocols. And there isn't. Oh, not in that one. Yeah, there it is. Implements node service. If light server equals nil, it'll do this. If it isn't nil, it'll have the subprotocols and. So this protocol manager is what's driving it. So the Ethereum has a protocol manager. New protocol manager. And this is all in the namespace. So if we go back to in handler. So if I look in handler / new protocol manager, returns a new Ethereum subprotocol manager. The Ethereum subprotocol manager's peers capable with the Ethereum network. returns a protocol manager. And then protocols. Subprotocols 0 version. So the protocol manager has a subprotocols array. Which is this array of peer-to-peer protocols. And I'm kind of wanting to look at what the defaults are for Ethereum. So subprotocols. Manager, is that protocol manager that's been made? Then they define here length of protocol versions. CD. So there's two versions of the Ethereum protocol, 63 and 62. So it goes through okay. So it offers the peer-to-peer protocols of ETH63 and ETH62. And it goes through those two. Version equals version. Manager.subprotocols append. Name equals protocol name. So where's the protocol name come from? Up here maybe? Not in there. ETH. So they define it as ETH. Protocol name is ETH. The version is 63 or 62. The length equals protocol lengths I. Run. Peer-to-peer. sub protocols downloader manager.downloader. So it gets a peer, they make a new peer, add the peer to the new peer channel, add it to the work group. If they receive it, manager.handle peer. Node info, peer info. So Ethereum offers 2 sub-protocols. Here's the stuff about downloader, which is synchronizing the chain, and handle is the callback when an ETH peer is done. And this gives it all the stuff to do the handshake. So all this information is shared with the peer that tries to connect. And then if you guys get the same thing, you're good. If you don't, the handshake will fail. Like if you're trying to talk with someone who's got a completely different chain, then you want that to fail. Register the peer in the downloader, so you can download from them. Handle incoming messages. Cool, so let's see. 63, what is that? Nope. Yeah, okay, here we go. So, the Ethereum wire protocol has fast synchronization. Alright, so this looks like something almost ready to delve into. Basic chain syncing, peers connect to say hello and send a status message. Worst total difficulty. p.handshake. So what's p? Is the peer. So, what have I got to look at? Type. So when the peer tries to connect, it gets passed to this function. This establishes the blockchain information, and it calls this peer handshake. And this peer structure has handshake, I guess. Executes the Ethereum protocol handshake. So they send status message. Status data. Where'd they get that from? Alright, Yeti. So I'm looking at the Ethereum Codebase, which is Geth. And there's quite a few Ethereum clients. Geth is the one that's made in Go. And I guess I'm trying to get my head around the Codebase because it's huge. And I know nothing about it. So I'm literally just digging through and trying to get my head around it. And when Geth is first called, don't know if you've had anything to do with it. You call Geth, and this is Ethereum client trying to connect to pretty much the Ethereum peer-to-peer network, and then it tries to sync and get the blockchain that you've got on your computer to match what's the current state of the blockchain. And the first thing Geth does when it's running is it starts this node. Where are we? Go up a bit. There is a node. And this guy here, its job is to start up the peer-to-peer server. It also starts up the the RPC, and so if you want to run this, here, it kind of sits in the background, but you can talk to it. So you can ask it what's going on the blockchain at the moment. And it does that through a few different ways. Inter-process communication, I think it's, I never can remember. IPC. Yeah, inter-process communication is one, and that's pretty much you write to a file that the server here is listening to. Another one is RPC, which is remote procedure call, which that's actually running a web server. So it listens to them, but you turn them on and off depending on what you want it to do. So the way that the node does that, and this is what, like, really diving into it, like it kind of makes sense conceptually that you've got this service that's running. You can choose whether it runs this this type of server or not. You turn it on or off. But the actual implementation's a bit all over the shop for a noob like me trying to understand it. So the way it does it is it's got a list of these APIs, and they are just calls you can make within this program that talks about the blockchain. And the stage I'm kind of at and what I'm looking at is when Ethereum first tries to connect to the network, it's got a list of peers that are hard-coded, and they're just safe ones that have been run that are going to be there till the end of days. And then the first thing it does, it asks them for more. So it's like your BitTorrent client. It'll go build a list of peers, and it knows that each one of those peers has like a blockchain saved on their computer locally. So the next job is to determine if one of those peers or all of those peers have a newer chain than what you've got, and if it does, to copy it. So what it does is you find a peer and you send this hello message to them. And that's just to say, hey, look, I've just joined this network. I'm going to want to talk to you. The reply back is just a standard hello as well. And it's got the status, which is just saying this total difficulty, which is the higher chain. So which one's newer, which one's had more work done on it, which is all the total difficulty is how much blocks it's going to have, and then the hash of their best block. So ideally, when you're at the newest block, you should have the same total difficulty and you should have the same hash of your best block. If not, the client with the worst one asks the one with the better one for information, really. Just says, can I have a copy of yours? And then we go into this handle procedure again. So a peer is disconnected. You've got to send to it some information. What are we going to send? I want to look at the peer. CD peer. That's why I have so much issue. I'm still there. CD go. Going to source. CD GitHub. Peer to peer. vmpeer.go. So you got a peer here, and you call the handshake function on them. Which is not there. Why is it not there? New peer. If I go handshake, so give me too many. Function handshake. It's not in there. I thought I had it before. Nah, because it's not in peer-to-peer. vmpeer here. Handshake. Executes the Ethereum protocol handshake, negotiating the version number. So you pass it the total difficulty and the hash of the head. So that's the two that they're talking about here. Protocol version, proof of concept, 6162. So where are they passing total difficulty? Total difficulty, blockchain get total difficulty. Cool. So this calling the blockchain structure to get those two. And then goes through error channels, peer-to-peer send p.rw. So what's RW then? Status data. Dial. So send. Don't want that in the other page, not on two at once. What am I doing? Go to Ethereum here. within message. .go. So we're going to send. And that's, yeah, so that's what they're calling here. They're sending a message writer status message. So where's the status message coming from then? Here. / status message. It's another constant, I guess. And the status data. So I want to go back into Ethereum. Oh, it's in protocol. So status message. Protocol messages belonging to the separate protocols. So it sends 0. So for the handshake, it sends a new block hashes. Sends a status of 0. Protocol version P. P. What's a P mean, you reckon, here? They don't say. Informs the peer of the current state. This should be sent. It's got a protocol version, network ID, total difficulty, best hash, genesis hash, which is exactly what's here. Protocol version. You send a status message. You say hello and send a status message. So you send this, which is this information. That gets sent. Then you go read status. And that is going to be here. So you get a message back from your peer. And they're going to have sent something similar. With their protocol versions, network IDs, and total difficulties and stuff. So the read status, network status genesis. So they call the read message. They get the message out of it, which is this message structure here. Peer-to-peer message. Send. Read message. Write message. Message structure. Code size payload. Error if not status message. So if they don't send a 0 back, then you get an error straight away. Protocol max message size. Max message. Yeah, okay, so they've set a limit. So you don't get spammed, I guess. They call decode on the message. Decode, it's right there. Which returns what? And to give a pointer. This is at status. Status, which is a pointer to status data. And they decode it into there. If the genesis block does not equal the same genesis block that you've sent, they spit out an error. If the network's different, it spits an error. Like if you're on a test net and they're on a the main net. Protocol version's different, which is at 62 or 63. And they just read it into that status data structure. Return nil. So status data. So what is status data then? In protocol? Status is a network packet which has the total difficulty current block. So that is called by this read status. So they pass the status down to it, and they just read it into it. So what do they do with it afterwards? Error, timeout C, defer timeout dot stop. Okay, so they set a timer. So they send a message, this status message saying hello, and then you get a message back into this read message function, and then they sit there waiting for if that read message comes back or not. They set a timer. I guess that handshake timer set here. 5 times 5 seconds they give you. If you don't receive back in 5 seconds, they will timeout.stop. For select. So they do this twice. They go in here and they wait for either an error message or the timeout. And they'll do that twice. It'll fail twice, I think. And then they get the peer total difficulty and the peer head out of the status, and they set it on the peer structure. Cool. So what do they do after that? They do the handshake. register to peer on your local one. And keep going on. So it's just maintaining this list of people who are possible people you can download information from and send information to. I think I might call it there today, but I want to look into and find out where the downloader sort of kicks in, because up to this point it's managing the peers and not doing anything with them at the moment. So at some point they're going to have to check, is your total difficulty higher than mine? And if it is, I want to download from you. And I'd like to find where that is and what that's doing. But anyway, thanks everyone for listening. Have a good day.